All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over, or one of the last things we went over, was the OR function in the truth table. Tonight, we're going to pick up with the N function in truth table. So let's take it from the top. And we can imagine trying to do this for other functions as well. A function like the N function, for example. So this is our N function, and this is our truth table. It takes two inputs and calculates whether both x and y are true. So x is 1 and y is 1. Then the output of x and y is 1 or true. As you can see here in this bottom entry here, you have x is 1, y is 1, which means the output is going to be 1. For any other circumstance, it's going to be 0 or false. That means both the outcomes or both the inputs have to be true in order for the output to be true, or else everything else is false or 0. But if in all the other cases, the output is 0 or false, like I mentioned, how can we model that inside of a neural network as well? Well, it turns out we can do it in the same way, except instead of -1 as the bias, we can use -2 as the bias instead. What does that end up looking like? Well, if we had 1 and 1, that should be 1, because true and true is equal to true. We take 1 times 1, that's 1, and 1 times 1, that's also 1 for both our inputs. That gives us a total sum of 2 so far. Now we add the bias of -2, which will give us the value of 0. And 0, when we plot it on the activation function, is just past the threshold, so the output is going to be 1, which is true. So this is what the equation looks like here. Let me move down a little bit further. So you can see we have our 1 and 1. 1 times 1 is 1. 1 times 1 is 1. We add those both together, that'll give us 2. 2 take away 2 is going to be 0. And if you plot 0 on our step function here, it'll put us just past the threshold, so that will make it true. So that will make this expression true. But what if we add another input, for example, like 1 and 0? We'll have 1 plus 0, which is 1, plus -2 is going to give us a -1, and -1 is not past the threshold, so the output is 0. So let's look at that. So you can see here we have 1 times 1, which is going to give us 1, and then 0 times 1, which is going to give us 0. Let me change that. That didn't change that one, sorry. So that's going to give us 0. So ultimately, this will be 1. So it'll be 1, take away -2, or plus -2, however you want to look at it, and that'll give us a -1. And -1, as you can see, is well before the threshold, so that's going to give us an output of 0, making the expression false. That was pretty much the same as we did last night, just a little bit different by using the step function. As you can see, manipulating those numbers to see what kind of outputs we get. But yeah, like I said, with the OR function was either one or the other could make it true. So if we had a 1 or a 0, the expression will be true. But with the N function, it has to be 1 and 1, or else everything is false. That's pretty much what we went over for tonight. I'm not going to dive too much deeper into it, because it's pretty much the same. We just took a lot of notes and summed up a lot, and we actually left off here at the gradient descent. That's where we're going to pick it up tomorrow. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.